Okay, students, we're going to talk specifically about the remainder and factor theorems here. In doing this, you use synthetic division, which we've already done before. We did synthetic division with long division. The remainder, when you divide the polynomial, is the constant f of a. That means if you plug a into that function, that's what you would get. So the remainder is what you'd get if you plug the function in. We've gone over this. I've explained this before, so let's just look at it here. First, you write your polynomial in standard form. So you see degree 4, 3, 2, 1, 0. Excuse me. If there was missing a term, it's like it went 4, 3, 1, 0, and missed the quadratic term, you'd have to plug in a 0 in for that. So just know that. So this is just another way. Instead of you having to plug it into the x's and do the calculations, you can use synthetic division. Instead of having to plug it into each one of these and then do all the calculations after that by hand. Again, this is, you're doing this without a graphing calculator or calculator at all. You can use synthetic division. So again, you write down your coefficients 3, 2, -5, 1, and the constant -2. I like to put that dash right there. So the one after that, the last one, is the remainder. Remember, you drop down the 3 to begin with. You multiply anytime you're down at the bottom here. So -2 times 3 is -6. -6 plus 2 is -4. Multiply again. 8. 8 minus 5 is 3. Multiply again. 3 times -2 is -6. Add again. -5. -5 times 2 is 10. 10 minus 2 is 8. Okay? So that's what you'd get if you plug -2 into that polynomial into all the x's and simplify it, you'd get 8. Method 2 is direct substitution. That's what I was just talking about. If you directly substitute it in there, you get all that and you get the 8. Okay? Our whole point here is for you to practice synthetic division. Okay? So plug in 3. So here, notice we're missing a term. We have 3, no second power, 1 and 0. So it's plugging a 0 there. Okay, drop it down. 15 times 3 is 45. 45 plus 2 is 47. 3 times 47, 141 minus 1 is 140. So the f of 3 is 140. Remember, that's function notation. Okay. So that's that side. Let's go to the other side. Factors of polynomials. The factors theorem can help you find all the factors of the polynomial. Okay, show that x plus 5 is a factor. If x plus 5 is a factor, then the remainder is 0. That's how you show it. Then find the remaining factors. Then you take the answer, what's left. So after I plug in, remember you go right in order, 3, 2, 1, 0. So it's 1, 2, -13, and 10. No missing terms, so I don't have to plug in 0 in anywhere. Drop it down, -5 plus 2, then it's -3. That's 15 minus 3 is 2, -10 plus 10 is 0. So that tells me x plus 5 is a factor. And then I have this quadratic left. Remember, this is degree 0, degree 1, and degree 2. So that says x squared minus 3x plus 2 equals 0. We're trying to now solve that. That's a nice easy factoring of x minus 2 and x minus 1. So here are my other two factors plus this factor. So all three factors in is x plus 5 times x minus 2 times x minus 1. That all multiplies back up to that right there, if you multiply it all back together. So it says find the remaining factors. Notice it didn't say to solve them, just says find the remaining factors. These are the factors. So there's my answer right there, which then you see right down there. Okay. So notice you're all starting with degree 3. They give you one of the factors that'll take you down to quadratics until you get down to the very last one. Okay. Where you have a cubic. So then you might try synthetic division and pick small numbers like 1 or -1 to see if it comes out to be 0. Or when your cubic is done, it might factor nicely into 2 groups of pairs to then factor out as well. All right, that goes ahead and ends this one right here.